For this problem, we're going to solve uh, systems of inequalities by graphing. And then once we graph, we're going to take the coordinates of the points where the lines intersect, and we're going to plug those into a function to find the highest and lowest value. So first of all, let's graph these inequalities. The first one that we have is y greater than or equal to 0. That would be all y points above the x-axis. So I'll draw this as a blue line across the bottom, and that would be shaded up. The next one, the easiest one to go to would be the third one. So 0 is less than or equal to x is less than or equal to 5. That's actually two inequalities together. We have 0 less than or equal to x, and we have x less than or equal to 5. So it's a range of numbers between 0 and 5 that contain x values. So x's that are greater than or equal to 0, that would be the y-axis. And then the x's that are less than or equal to 5, if we go to 5 on the number line and draw a line straight up, this would be the shaded area, 0 less than or equal to x less than or equal to 5. So that would be the area inside. So far we have the area that's bound by y greater than or equal to 0 and 0 less than or equal to x less than or equal to 5. So notice how everything's in the first quadrant. The next inequality we want to look at is the second one, and that's minus x plus y is less than or equal to 2. So we can use our x and y intercepts for that. If we let x equal 0, y is equal to 2. And if we let y equal 0, x is equal to negative 2. So y is equal to 2, x is equal to negative 2. So all we need to do is plot those 2 points, draw a line in between. So we'll go to negative 2 for the x, which will be here, positive 2 for the y, which will be here, and we will draw a line that goes up. Notice the part to the left of the y-axis is not included, so I can erase that just so that we know that we're inside this bounded region. And now the last one to graph would be x plus y is less than or equal to 6. I hope you can see very quickly as we look at that, less than or equal to 6. If we use x and y intercepts, x equals 6 and y equals 6. So we can go to those 2 points. X equals 6, I'm going to put this in a different color, would be here. Y equals 6 would be here. And so we will draw a line between those 2 points. So now that we've graphed all of our inequalities, the shaded region that we'll be working in is this area inside here that I'm coloring in yellow. But what we're really focusing on is not so much the shaded area, but the points where those lines or inequalities intersect. Let's go ahead and put all of these in green. We have the origin. We have this point, which is 0, 2. We have the origin, 0, 0. We have this point in the middle, which we know if we graph this using lines would be 2, 4. Notice mine is slightly off, but if we use the actual straight lines, it would be 2, 4. The other 2 points are 5, 1. That would be this line here. And then the last one would be 5, 0, this point. So there are our 5 points. And now what we want to do is find the minimum and maximum value. And in this problem, we're given a function, an f of xy, and it's equal to 5x minus 3y. So what we need to do is plug in those coordinates, x's and y's, and evaluate. So the first one we'll evaluate will be f of 0, 0, which, 5 times 0 minus 3 times 0, that would be 0. The second one, f of 5, 0, that would be 5 times 5 minus 3 times 0, so that would be 25. Next point would be f of 5, 1. That would be 5 times 5 minus 3 times 1, so that would be 25 minus 3, or 22. Next point would be f of 2, 4. So that would be 5 times 2 minus 3 times 4. So that's 10 minus 12, or negative 2. And the last one is f of 0, 2. That would be 5 times 0 minus 3 times 2. So minus 3 times 2 is minus 6. So if we're looking at minimum and maximum values, the minimum value I'll put in yellow would be negative 6. So it would be at that point 0, 2. The maximum value is 25. That would be the one in purple, f of 5, 0.